everyone. This is Cody Jackson for Cody Mom, and we are continuing our Python adventure looking at object-oriented programming this time. Usual plug, again, you've seen it before. We are about halfway through the Learn Programming in Python book. Here shortly we will be moving into actual programming of the simulation that is described in that book. So if you want more details that I'm not going to cover in the video, I do recommend taking a look at that book, simply because it does have more information than I will be including in these videos. Secret Recipes of the Python Ninja is also available. If you're familiar with Python, it basically just kind of goes into actual step-by-step demonstrations of particular things such as multi-threading, multiprocessing, how to use the math library, things like that. Alright, jumping in. OOP fundamentals, object-oriented programming fundamentals. So what is OOP? OOP is basically an improvement upon functions. Now, I do put a caveat in here saying that Python allows you to use either functions or objects. Even I'm mixing those two together within the same program, and that's really beneficial because if you work with program languages such as Java, where you have to use the object-oriented paradigm, a simple hello world program can turn into half a dozen lines of boilerplate just to get the hello world printed to the screen. If you used a function, it's basically, two words or two lines. Define your function and print hello world. So the benefit primarily is that you can use functions or objects depending on what is best for that particular purpose. And we'll discuss further what object-oriented programming provides you that you don't get from functions. But recognize that functions in and of themselves, as part of procedural programming, is not a bad thing. The Linux operating system is built using C primarily, and C does not know objects. And so everything that is Linux is procedural programming. It's functions. And so as long as you have a good design plan, you don't have to have objects. A lot of times objects can get into the way of your programming because you're so focused on how to interact with those objects that you lose track of what it is that you're trying to do. And there's a lot of overhead associated with dealing with objects that you don't have to have with functions. So, that out of the way, OOP improves on the reusability of functions by combining functions with other parameters. So we talked previously about how functions allow you to basically reuse that same code over and over again without copying and pasting it. And so object-oriented programming goes a step further by creating a class object that has a number of functions included in it, but also some parameters and other objects that all become a cohesive structure, a data structure. Object-oriented programming and classes, we'll talk about classes specifically, but just recognize when you talk about OOP, generally speaking, you're talking about classes. So a class provides a basic template for a theme, whatever you define that theme to be. It could be representative of something in the real world, such as a house, or parts of a house, or a car, things like that. Or it could be purely virtual, just something that exists within the logic of a computer. Anyways, you have this basic template. You provide it some default behavior, some default parameters, and you utilize that basic class through instances of that class. And I've never really found a good way to explain instances to people, but just recognize that an instance is, if you say like an instance in time, that particular point in time is the instance that you're talking about. Same thing with classes. That instance of a class, that particular moment in computer logic that class exists, is an instant. But just like you can have multiple instances of time, you can have multiple instances of a class. Each instance of a class is separate from the other instances, but they all reach back to that foundational basic class, implementing them in separate instances. A class can have a number of methods, and get used to that term, methods. A method is nothing more than a function wrapped within a class. So if I say method, just recognize that I'm talking about functions. There's also self-contained parameters. So those are basically going to be variables that are tied just to that class. And then you also have the ability of inheriting properties and functionality from other classes as well. We'll talk later about it, but part of that inheritance is that you can inherit only those aspects that you care about, and you can ignore things that don't apply to a particular class, or you can change how a method is used within a subclass. You can create new functionality within that subclass. It kind of doesn't make sense right now because we're not showing anything, we're just talking about it. But I want to at least put these words out there so that you understand what we're going towards. So this is, again, not going to mean too much because you're not going to see the code on the screen, but at least we'll talk about what some of these principles mean, and hopefully you'll understand a little bit more about why classes are so useful. So if we have a base class, which is going to be vehicle, and this is the most generic vehicle you can define, so it could apply to any vehicle ever. It's going to have parameters for the number of doors, number of wheels, engine type, if any, the construction material, what it's used on, land, sea, air, stuff like that. It may also have methods for acceleration, braking, top speed, turning radius, things like that. And if you have your methods using the parameters as input arguments, changing those input parameters can change the output that method creates. So if you have a base vehicle class, then you can inherit all of those parameters and methods that base class has and create specific types of vehicles. So these would be subclasses of vehicle. You would have a bicycle class, an automobile class, an airplane class, a helicopter class, a boat class, things like that. Those are all taking that basic formula that your vehicle class has, the parameters and the methods, and then specializing it for that particular object that you're talking about. So a bicycle isn't going to have any doors, but it's going to have wheels. It's not going to have an engine. It's going to have a type of construction material. All of those are going to be different than what you would have in a pickup class, where a pickup truck is going to have doors, it is going to have an engine, and things like that. Because you have the inheritance of these subclasses, or I should say the inheritance of the base class, or the parent class if you will, into the subclasses, also known as children classes, You can use what you need, throw out what you don't need, and change or create new items that you need. So for example, the bicycle class inherits from the base vehicle class, and like I said, it has no doors. So that parameter, number of doors, is ignored for bicycle. But it has pedals, and so maybe that's something that you want to create as a parameter for your bicycle class, because there's different types of bicycles, and not all of them have foot pedals. Some of them have hand pedals for people who are disabled. So individual instances of these classes create a specific logical object of your class, and that instance is separate from any other instances. So you can have bicycle 1, bicycle 2, bicycle 3. They're all distinctly different, but they all are inheriting from that base vehicle class. So they all have the same parameters, the same functionality and stuff like that, but they're each uniquely different. We're going to jump into discussing namespaces before we actually talk about some code examples of object-oriented programming. So we had talked about namespaces when we talked about modules. Classes have their own namespace as well. So anything that's part of a class, whether it's a parameter, whether it's a method, anything like that, anything that is encased within that class wrapper, is unique to that class. You cannot call parts of another class directly. You have to specify which class or instance you want to use, dot that parameter or the method. So you basically have to use dot nomenclature to access these components within other classes and other instances of classes. One of the reasons for this is kind of like a URL, where you have to specify exactly what part of a website you want to access, but it also helps with variable shadowing, so that you don't have the same name in one class that might have the same name in another class, and if you did not qualify it with that class name, your computer program would not know what it is that you're talking to. And we talked about how instances have their own namespace. The instance has its namespace. It also has access to its class namespace. And so if there was a parameter that was not used in an instance, but it's part of the base class, and suddenly you decide that you need it, you can evoke it by calling the base class's namespace and accessing that particular object, whatever that may be, a method, a parameter, whatever. Some of the basic concepts and terminology we'll talk about right now. So when you create a class, you use the class name keyword to define that class. So kind of like what we did with functions, where you have def as the keyword that defines your function, class defines your class. When you call the class keyword, it defines the class object, gives it a name, and then creates that class's namespace within memory. And at that point, you have established everything that you need at the bare minimum for that class. Variable assignment and methods in a class are attributes. These attributes are accessed via dot nomenclature. We already talked about that. The class attributes give access to the object's state and behavior. All instances of the class share those attributes. And again, this is just reiterating what we've already talked about. Instances of classes copy or create copies of the class separated by individual namespaces. Again, just restating what we've already talked about. Instances have access to the base class's attributes plus whatever's within that instance namespace. Should sound familiar. The term self helps Python identify which particular instance is being discussed so that you don't get accessing the incorrect items within a particular instance. In Java, I think it's called this. Other object-oriented languages have different ways of identifying what instance is calling the class. In Python, it happens to be self. Alright, so let's actually look at some code and see what we've been talking around for the last couple of minutes. Alright, so I jumped ahead and wrote out a whole bunch of code here, and we'll just kind of walk through it step by step. So in line 1, we define our class, and this class is named Knight. And we define two methods for it. One is setName, the other is display. So setName takes, okay, don't get confused by anything. These are functioning just like regular functions. The only thing that's different is the very first argument in a method has to be self if it's an instance method. You can have class methods that don't take self, but we're not going to talk about this right now. Just assume if you're talking about methods, the first argument must be self, otherwise you'll get an error. So if we were setting a name with a function, we would have an argument of name coming in and then doing something with it. In this case, we are defining the instance name, so the variable name for a particular instance, and you can have a dozen instances. They're each going to have a name variable, but they are identified by each instance's self. Hope that makes sense. In this case, the argument that comes in, name, is going to be assigned to the variable self.name. And that's basically just saying for every instance, it's going to assign the name argument to that instance's name variable. For our display method, there is no argument. Self is the only thing. So that basically just says for every instance, it's going to have access to a display method. And this display method, all it does is print the variable name to the screen. We go ahead and we create 3 instances of Knights, and that just shows that we have a single class, but we have multiple instances of that class. So if we call Knight A name, then it's going to tell us there is no attribute name of name. And that's because we haven't given it a name. All we did was create that class. So if we call the setName method using dot nomenclature, so specify which particular instance we want to work with, and then the method that we want to work with, and then the data value that is going to be assigned to it. In this case, sirloin is going to be the name of this particular Knight. If we try to access that name again, and we get a different error. Notice that first it said there is no attributive name. Second, the second time that we called it, it tells us the string object is not callable. But if we call a.display, meaning we are calling the particular instance A, we are calling its access of display here, it's going to print the name associated with that instance, in this case, sirloin. I hope that all made sense. if we do the same with B, if we just call B as is, it's just going to tell us that we have a instance of the night class at a particular memory location, but there's nothing associated with it. If we try to call B name, we should get the exact same error that we got for trying to do it for A. And if we call B display, it's not going to give us anything because we've never assigned it a name. And it comes back and it tells us night object has no attribute name. We've never defined a name for the instance of B. Now, one thing you can do, rather than explicitly calling the method name, is you can call the parameter that you want to work with, in this case name, and assign it at that time. So in this case, rather than just calling c.name, which isn't going to give us anything, it's just going to give us an error, at the exact same time that we are trying to call the name parameter for instance C, we assign it a value, then we can go ahead and use the display method to give us that name. So you have two options. You can either explicitly call the setName method, as we did here for A, or you can do a parameter interaction, c.name, and assign it the value that you want it to have at the exact same time. It's your choice. Before we leave this video, I want to talk briefly about initializing a instance. You'll see this a lot. And so you can have a special method called the initialization method, and it's basically double underscore init double underscore. Double underscore is often called dunder for double under. And anyways, anything you define in initialization method is automatically handled upon instance creation. So in this case, we get rid of the setName method and just set up the name as part of the initialization of an instance. We still have the display in there for now. So if we define our instance X is a night and we provided a name at the time of creation of that instance, then that name is immediately assigned to that instance. Now, if you wanted to do other things during initialization, you can have other methods called. You can access other classes if you need to during that initialization. But it's really just when a instance of a class is initialized, when that creation occurs, you can give it all of its starting parameters. So just went ahead and showed you that there's nothing different that we did here. If you just call the instance, you still get that it's an instance of a class at a memory location. If you still call the name variable directly, you still get the same error where the string is not callable. If you want to go ahead and change the name of the instance to sirnew, then you call display again. You see that sirnew has changed from the original of sirx. So it's the exact same thing that we've been doing. The only thing that's changed is when the instance is created, we can give it a name. Previously, we had to set the name as a separate step. One thing to note, if you do decide to use an initialization method and you don't provide the input parameters that it wants, you'll get an error telling you that you are missing parameters for the initialization. So it's kind of a trade-off. if you don't mind providing all of the input data at creation, go ahead and use initialization. If you want a little bit more control, then set up a method to do it expressly. One cheater's way around it, though, is by providing a default value as part of the initialization. So in this case, we've done the exact same class, except that we've assigned a default value for name when a class is initialized. So if you don't provide it with a name, it will give it a default value. In this case, Sir Boring. We've created a knight. We did not provide it a name, but it has a name by default. And so that alleviates that error message about you didn't have an argument being provided. There's a lot more to this. I don't want to go into a lot of detail right now. So we're going to wrap up this video. We talked about the basics of object-oriented programming. Sorry about the noise. I accidentally hit my table, which is plugged in, which my microphone is mounted to. Example of a base class as inherited to create individual classes. We talked about namespaces, and then we gave an example of class, method, and instance creation. So there's a lot more to classes than what we talked about here. This is just the basics. As we go along, we will talk about different things that you can do with classes. Starting with 3.8, I think it is, Python 3.8, you can actually eliminate that whole initialization method and just go through and assign parameters directly by using a data class property. And that basically gives you some class methods automatically that you would formally have to do manually, such as the initialization and stuff like that. So Python's always changing. A lot of what I tell you now is old, but a lot of Python code you're going to see is old, and so you're going to see a lot of the paradigms that I talk about in your code, or not in your code, but in code that you see. So I'm going to try and keep things as relevant to the current edition as possible, but there's going to be some things that are going to be older on purpose, or just the code examples that I haven't bothered to update because there's no need to. So next time, we're going to talk a little bit more about modules, class inheritance, and operator overloading. So, as usual, I hope you found this video informative and educational. If you have any questions, comments, concerns, just let us know in the comments. And until next time, continue learning and have fun. Thanks.